Alright, this video is going to be a whole mixture of different limits of functions and bringing in those review ideas for how we can simplify functions as we work with them. Again, what I highly recommend, especially if you've gone through watching those last videos, try these first before watching the video. So try writing up your own solutions and then check your work as we go through this and fill in any blanks where you weren't sure how to work through the problems. Okay, first example here. So where I'll start with all of these is trying direct substitution. This one is going to work great for that. So we'd have a negative 0 cubed plus 2 times 0 squared minus 3. All of that is just going to evaluate to a negative 3. No issues there. Direct substitution works great for plugging into, in this case, a cubic function, but really plugging into any sort of polynomial, we're going to be good to go. The next scenario, what I would really be wary of is plugging into the denominator here. So if I plug in a negative 3, so I'd have a 9 minus 24, which would be, and then a plus 16. That's all sounding pretty good. So with that, let's go ahead and just plug in. So we'll have a negative 3 plus 5 over negative 3 squared. Why I hesitated there is that I sometimes, because of the ones I choose, I almost expected it to fall apart, but it didn't, and that's totally okay. That's even better. Okay, so that'll be a 2 in the numerator, and then we'll have a 9 minus 24 plus 16 in the denominator, which is going to just be a positive 1. So all that's going to evaluate to a 2. Again, if you're in doubt, graph the function. In this case, it's just defined there, so this would be that we're graphing a coordinate, negative 3, positive 2. But even if in our initial form it's undefined, with that function you can look graphically at what value are we approaching from both sides, in this case, negative 3. This one's nice and easy because we can't even do direct substitution. Our variable isn't there, so if we're taking the limit of just a constant, our rule says that's just equal to that same constant. And this is probably our shortest form of direct substitution because we're just plugging in 3 for x, so all we'd have at the end of this is a 3. So we just want to keep those limit laws in mind as we go through these. Okay, the next one, if I try to plug in 1, what I'm really concerned about is that denominator there, which I would be getting a 0 out. So with that, I need to do some simplifying first. So before evaluating plugging in positive 1, I'm still taking the limit as x approaches 1, so we still need that notation there. And then I'm going to factor the numerator. In this case, it would be an x minus 1 times x minus 4. And then I have an x minus 1 in the denominator. So x minus 1s can cancel out. So really I'm evaluating the limit as x approaches 1 of just x minus 4. So now I can plug in 1 minus 4 for a negative 3. Again, I just want to be clear that we keep that limit notation until that step that we plug in the positive 1. And now we don't need to have our limit notation because we're evaluating the limit with those values plugged in and just getting a number at the end. Okay, this next one, we didn't have an example like this. So this is a complex rational expression. So we'll go through the steps for how to simplify a complex rational expression here. So what's making it complex is basically that we have a fraction within a fraction. So we have this denominator within the denominator, and there's a few ways that we can simplify this, but what I find is the most direct way is that we multiply the overall numerator and the overall denominator. We have to multiply by the same things that we're multiplying by a version of 1. And what we'll use is that complex denominator. So negative 1 plus x, negative 1 plus x. So up in the numerator, we'll go ahead and distribute x into the parentheses there. And then in the denominator, this negative 1 plus x is going to distribute in as well. So step by step, in the numerator, we'll have x times negative 1 plus x times x for an x squared. Down here, so why we chose that value is because then we'll get a cancellation. So that negative 1 plus x cancels out with a negative 1 plus x. So all we have is a 1 left over there. And then we'll go plus 1 times that negative 1 plus x. So we'll have a negative 1 plus x. So we have our two terms there. The first term turned into 1 because it was all cancellation. So all we had left over was that 1 from that numerator. And then we have our plus, and then it's just 1 times that expression of negative 1 plus x. Okay, so this is a bit of an extra step that I did here, but usually with the numerator we want to simplify it and then factor. I'm going to go ahead and factor out, can either do x or negative x. Let's go ahead with positive x. And that'll leave us with a negative 1 plus x. And then down here, 1 plus a negative 1 turns into 0, so all we have is an x left over. So with that, we can see the x's cancel out. So then all we're evaluating is the limit as x approaches 1 of negative 1 plus x. And now we can plug in 1, so negative 1 plus 1 turns into 0. So if you have fractions within a fraction, we can use this method of multiplying the numerator and denominator by the least common denominator of those complex fractions, and then that'll lead to simplifying our messy rational. Okay, next up. With this one, what I'm seeing is a square root, and it's being subtracted with something. So with that, that's bringing up that idea that I did in the last video, which is multiplying by the conjugate. So we have these expressions in the numerator and denominator. Sorry, before I even did that, I should have tried to plug in 4, but square root of 4 is going to turn into 2, which is going to give a big 0 in that denominator, which is an issue. If this was any other number, we could just plug it in, get that number out, and be done. But because it's creating that 0 in the denominator, we need to go through these extra steps. So multiplying by the conjugate, again, I'm only focused on that expression with the square root, so square root of x minus 2. So I want to use the square root of x. I want to use the 2, but what I want to multiply by has the opposite sign, which would be addition. And whatever I do there, I also need to do up here. So in the numerator, I'm going to go ahead and leave the numerator factored. I want to see where we land with that denominator. So we'll have an x minus 4 times a square root x plus 2 over, and then this will be our difference of squares, so square root of x times square root of x is just x, and then negative 2 times positive 2, so we'll have a minus 4. And there we can actually see our common factors. So really we're just evaluating the limit as x approaches 4 of square root of x plus 2. So we'll have square root of 4 plus 2, which 2 plus 2 is 4. So this uses our multiplying of conjugates because we're working with radicals and need to simplify with radical. Okay, our last example here deals with the piecewise function. And there's a few ways to go about this one too, but for me, I like to go visual whenever I can here. So we're given two functions. The negative 2x plus 8 is working when x is smaller than 2. X minus 1 we're using when x is larger than or equal to 2. So what I can do is even imagine if I had a number line and really I'm focused on 2 and then I have 0, 1 below it, 3, 4 above it. So at x equals 2, so for values x less than 2. So not including 2, but everything smaller, we're using negative 2x plus 8. And then we're using the function x minus 1 for any values equal to 2 or larger. So for the limit, if we're evaluating x approaching 2 from the right-hand side, then what I'm thinking of is I'm over here with the larger values. I'm getting closer and closer to 2 from over on this right-hand side, which means I'm focused on this function x minus 1. So if I'm evaluating this limit, x approaches 2 from the right, where I have these 2 options for my function, because I'm approaching from the right-hand side, I'm focusing on just x minus 1. And then with that, I can go ahead and plug in 2, so 2 minus 1, which leaves us with 1 as a final answer. So if this had been x approaching 2 from the left-hand side, then we would use negative 2x plus 8. And then if we were saying from both sides, it would only exist if they lined up to be the same value. If we evaluated from the right-hand side and left-hand side, in this case, they land 2 different spots, so it would be equal. But with that, I like this kind of number line route to see what's happening on the left-hand side, what's happening on the right-hand side without actually graphing the functions, so that then you know whichever side you're approaching from, that's the function you want to use to evaluate.